For our next talk, we have Ingolf Pernis and George Gensen. And they will be presenting a paper who is also co-authored by Herman Eldner, who will not be joining us. The title of their paper is Cryptocurrencies and the Velocity of Money. And Ingolf and George are both research associates at the Weizenbaum Institute of Network Society in the interdisciplinary research group Trust in Distributed Environments. Why don't we give them a moment to get their presentation up?
Yeah, thank you so much for this nice introduction. We're really pleased to be here. For us as sort of junior researchers, it's of course a big pleasure to be here in Boston at a conference hosted by MIT. That's of course awesome and a big thing, and we're really thankful to Wasim to went through with it despite of Corona, so thank you for that. When the presentation is ready, we can start. Really, before just getting into all the details, I just want to give you a quick outline what we will be talking about today, but not with this presentation, I guess. We will talk, our research project is part of a recent stream of literature which is taking a look on how you could measure the velocity of money for cryptocurrencies. And doing so, we operationalize, that means implement a novel measure which takes not the total coin supply as basis, but rather money in effective circulation. Thanks, George. Yeah, here it is. Perfect. Thank you. And doing so, we of course have to unify and to replicate all the measures that exist out there. And having done that, of course, we want to take a look how well the estimation or approximation techniques that have been very popular until now really approximate these measures. Of course, this is a lot of information for many of you that are now economists, and velocity of money is probably not a known concept, so let's dive into it with a very nice example, which is quite colorful. So, meet Alice and Bob. Alice and Bob are quite rich. They have each a gold coin and animals. But we don't want to brush over important details. That's not only animals, but that's Dolly, and here we have Sven. And Alice and Bob want to trade. Alice wants the cow, Bob wants the sheep. How would they do that? So Bob would just give the cow to Alice and receives Alice's gold coin, and Alice would just receive the gold coin of Bob and give him the sheep Dolly. We would represent that as a price vector with the prices, so we have here the coins per sheep, 1, and 1 coin per cow, and a transaction vector in units of account. So 1 sheep has been transacted and 1 cow. If we take the scalar product out of that, we can calculate the transaction volume, that is 2 coins. So 1 times 1 plus 1 times 1. And the nice thing is that the units cancel out, so it's a monetary volume. What happens now if 1 coin just gets lost and evaporates? We have only 1 coin left, and can we still process a transaction volume of 2? It turns out that we can quite easily so. So Bob just needs to circulate this coin twice and not using his own coin. What happened? So before the loss, we had 2 coins, which on average were transacted 1 time. So 2 times 1 equals a transaction volume of 2. And after the loss, we had 1 coin left, and we turned that over on average, or it was only 1 coin, 2 times, so 1 times 2 equals 2 coins, again. On here, we are already at this concept of velocity of money. So velocity is this average turnover. And of course, you can see now also why velocity of money is so important for economists, because if you want to relate the money in circulation with prices and transaction volumes, you need to take into account also the velocity of money. And you see as well, if you don't know this velocity and you want to back it out, you can simply do that using the transaction volume and the money in circulation. So we would divide transaction volume of 2 here by 2 and get the velocity of 1, and here 2 by 1 and get 2. In general, that means that we would calculate the velocity as transaction volume divided by money in circulation. Of course, we can express this also a little bit more in a formal way. Here we have this concept again, and it's now a good point to note that it's the transaction form of the quantity theory of money of Fisher, 1911. We have here again this vector, the scalar product of prices and transactions, the money supply and velocity. Now, of course, you understand also much better what we did. So we somehow implemented a measure that is adjusting this money supply, and we compared measures that are using this form to approximation variables that are using some other variable in order to approximate this velocity. Well, if we want to develop a novel measure, we of course need to know what is out there already, and there are two ways to measure velocity out there until now. We have the first one by Bolt and Van Oort in 2016, and that was introduced there theoretically and used for the first time by Sayan et al. In 2018 in a pricing model. And it just uses the raw on-chain transaction data, transaction volume on-chain, and divides it by the total coin supply. Of course, we have here artifacts in the transaction volume because we have change money, and change money is not used to be used, or it's no real economic transaction to other people, but it's just shuffling money from pocket to pocket. And actually, we have a really nice quote from Fisher here. What is desired is the rate at which money is used for purchasing goods, not for making change. And that sounds like from today for cryptocurrencies, but it's actually 100 years old. So how would we do that now for UTXO-based cryptocurrencies? George, please.
Thank you. Yeah, so we have a transaction of financial histories ordered in a transaction graph where transaction inputs are linked back to transaction outputs. And as you know, the order of that is ensured by the infamous underlying concept of the blockchain. So since we are focusing on the velocity of money rather than technical aspects, we simply shove that into the background, stuff like proof of work and cryptography, and simply focus on those components of cryptocurrencies that apply to us. And these are namely the transactions having inputs and outputs, where inputs are linked back to outputs. And in order to derive a measurement, we have to first compute transaction volume, which is basically the all summed up outputs within a certain period for which we want to calculate the velocity. And for the denominator, we need the coin supply, which, as you may recall, Bitcoin creates coins that are mined within Coinbase transactions that do not have any inputs. So we were basically to sum up all the mined coins up to a point so that total coin supply is a function of a block high that we are actually. So this is a rather trivial measurement, and in order to adjust that, the first step Ingolf mentioned is to adjust for change transactions. So now we have a change here, and note that for the time of this talk, all outputs that you see are regarded as outputs that go to other entities rather than representing shuffling money over multiple transactions belonging to the same person from pocket to pocket. So we exclude them and have an adjusted on-chain transaction volume, which we call the total velocity since the trivial part is gone. And now the question is the total money in circulation, the total supply of money a good measurement? What do you say, Ingolf?
Yeah, thank you. Now, it of course gets to the question what really money is, and this gets quite philosophical and out of hand. But let's keep it simple. You could of course use just the total coin supply, it's just a definition and not wrong per se. However, you might want to define money with respect to its functions. And Dalton in 1965 coined that quite nicely as money is what money does. And that is, of course, like it relates to the functions of money. So what does money do is the question. And money is doing its three functions. So money is used as medium of exchange, storage, and denominator of value. However, cryptocurrencies are really this weird two-sided asset which is used by some people for speculation only and held as investment, and by others as medium of exchange. So it makes intuitively sense to segregate the money supply in one part that is used as like hoarded and held as a speculative asset, and one part that is really used for transaction making. And this has been done also concept-wise by Fisher in 1922 or Keynes in 1973, but also in more modern papers by cryptocurrency pricing models. So, for example, Athey in 2016 or Bolt et al. 2016 were using the concept of money in circulation to relate feedback loops between expected price increases and real price increases in a way that agents were expecting price to increase, then increase the fraction of money that was held, and in decreasing the amount of money we're actually circulating, and thus pushing prices up. However, also technically, it makes a lot of sense to exclude certain units of money, especially those which have been burned, or for those that keys have been lost. Of course, they can't circulate, and now it's also the question, or we can answer how we define really money in effective circulation. We just would take monetary units that have been moved or touched within a certain point or a certain period of time. So we could say, for example, money should be circulating within the last year, and then we would say that money that, for example, have been created and used by Satoshi Nakamoto in 2009 wouldn't be part of the money in the effective circulation. If we use this different definition of money supply as base for our velocity measure, we would get also a different interpretation, of course. And that would be now the average number of turnovers for effectively circulating money units. Why this works, we don't have time to explain right now, but you can find it in a quick derivation in our paper. The question is how we can implement that for cryptocurrencies again now, practically. And here again, George will explain our methods.
Yeah, thank you again. So we developed two measurements that we distinguish like that. Meet again Alice and Bob. And this time, Alice wants to buy this sheep. Cow, I'm sorry. And she has this $100 note, and the cow is $1 per cow. So now you could consider money in effective circulation like this whole banknote has been moved and you only count that, or you include the change back, which is $99, and you only count this $1. So, and we distinguish those two approaches. So first of all, when we were to develop an algorithm, which we actually did, then the first step would be to derive raw data and parse them into a format that we can use. And we used Blocksci from Kelowna and Alpha for that, and we highly recommend to use that. And we were really grateful that we didn't have to do this work again. And the transaction volume actually is just getting all the outputs, summing them up, getting back the change by applying change heuristics, since you know we don't have accounts, so we don't know which coin went to which person. So this is strange. Yeah, well, then the first approach would be that you would collect all the transactions belonging to a certain period of time for which you want to develop, measure the velocity of money. And our condition, if we count an input, is that input coming from an output right before our period. So we simply count that. And since we, for the first approach, which we call whole bill approach, don't exclude change, we simply count the coins, and then we go to the next transaction, check the inputs there, and if they were respent within that period, we discard them, since we only count one coin and we don't want to count that again, right? And so you have this money supply within a period, and you can calculate the velocity here. And for the second approach, you want to discard the change, so you use all those outputs as an upper cap for summing up the inputs you want to count, the money you want to count for being in effective circulation. And now here comes the point. We do not know which input goes to which output. So we have to have some assignment rule for that. And we employ two assignment rules, the first in, first out, and the last in, last out approach. first in means you take the oldest transaction having an input being linked to the transaction you count, and assign them to the first output you count. You don't count the change outputs, of course. And you count up to the whole sum of the change outputs. So, and then you apply the same rule we had earlier. You go to the next transaction you have, and if you spent a coin, you don't count that again. And if you apply the last in, last out, or the first in, first out rule, then you might end up with a different supply of money in circulation, because since you resort them, and in the last in, last out approach, you take the youngest input and assign them to the first output, and so on. You might meet a coin that has been respent, and you don't count them. So that means that you have possibly two different values for the supply in circulation. So, and since this is data that we retrieved by developing our algorithms, the question is, if you don't have that data, you simply want to take data that is there, you can retrieve for 2 clicks, which measurement approximate best to our velocity measurements? Yeah, and that's a question that Ingolf is going to answer.
Yeah, thank you, George. You really struggled well through without the slides. I'm amazed. Yeah, the question is now, as I said, or as he said, if we want to use approximate data, which also pricing models used until now, what would approximate the measures best? And you didn't see it now, but they're quite complex and take a lot of computation power, a lot of brain power to really understand them. It's quite annoying. So maybe you want some approximates. So if you talk about approximates, what first comes to mind is CoinDesk Destroyed, and this was used in almost all empirical pricing papers for cryptocurrencies trying to relate velocity and prices. However, those didn't find, in most instances, significant relationships, so there might be room for improvement. CoinDesk Destroyed is really easy to download in a lot of online resources for free, so that's probably why it was used so much. Then, of course, there's another measure which was developed recently with a very nice interpretation, and also quite nicely to gather approximate coin turnovers by Smith in 2017. And this measure is also quite easy to download or to make yourself, because you can just use CoinDesk Destroyed and reformat it with on-chain transaction volumes. And lastly, you could just use the simple measure we introduced in the beginning. So just using on-chain transaction volume on total coin supply and trying to use that in order to approximate for the velocity of money. So which of those should you use then is the question. We will probably hope it is CoinDesk Destroyed because pricing paper used it so much, but it turns out it is not. It yields actually the farthest deviations from all the measures, not only ours, but also the others that were proposed earlier. And the question is how we test that, of course. We did use Bitcoin data, daily data from 2013 to 2019. And in order to bring them to the same scale, we used normalization and standardization to squish them together in a different way. We punished for difference for very strong deviations by mean average errors and mean squared errors. We used raw and first differences because pricing papers usually use first differences in order to account for common trends, stuff like that. And we did tests for significance using a model confidence test by Hans and al. 2011. And so we hope that our results are fairly robust. So concluding, what did we do? Most importantly, we did develop or implement this new measure for velocity of money, which is based on money in circulation. Then we did this benchmarking study for the approximation techniques used so far and found that CoinDesk Destroyed might be reevaluated as an approximation variable, and maybe this simple ratio might be preferable. Of course, no study is without limitations, but they are also future research for us, so it's good for us. So we did only use on-chain data so far. Probably if you would use trading data from exchanges as part of the transaction volume, you would get additional information on price determination on markets. Also, we did only replicate the heuristics from Carlotton et al., and we didn't put too much effort into that. So if you would apply modern, very developed and sophisticated heuristics, you might get a more precise measure. Of course, we could also augment this benchmarking study. We could use different coins, apply structural breaks, stuff like that to get deeper into that. And lastly, of course, we did also not yet really analyze our data, so there's a lot to be done in econometric terms. So hopefully there are a lot of papers to come. Thank you for your attention, and we're waiting for questions.
That's great, thank you. Okay, we have time for a couple of questions. If you have a question, please go up to the mic. Nick already has a question, so please.
Hey guys, thank you. In terms of evaluating active supply, that was part of the methodology.
Get a little bit closer to the mic, Nick.
Did you have a window size that you preferred in terms of determining what you constitute to be active supply? I presume you mean in terms of like the trailing set of coins that have moved within some prior window?
Yeah, that's
awesome
very,
question. We
very
hope
good.
that somebody will ask that.
So in our benchmarking study, we used this daily data. That means daily in terms of velocity, but also we did account for money in circulation, only money that was used in this day. However, I think that is probably the most interesting way to extend the study, to take a look at the best window size in order to get the most out of this measure. So somehow use the training set and evaluation set and find which window size would get the best approximation or the best correlation with prices, basically. Yeah.
Yeah, not even the single period or window, but you can take just the transaction volume of a certain period of time, and you can extend this condition point where you consider coins to be counted in the denominator for the money supply. So actually, this is like 2 windows or periods, and this is also a ratio that has to be explored.
But so you don't for that for the denominator, you didn't have a period that you're proposing as like.
No.
Okay.
So I have a question. So does your model account for on-chain and even off-chain assets that may act like money but don't look like Bitcoin transactions on the chain? For example, one example would be, let's say, transactions within the same exchange that don't go on the blockchain, or Lightning Network transactions, because you could have a lot of money supply in these sort of not really Bitcoin, but actually also Bitcoin things, right?
Yeah. So two ways of, or two types of off-chain transaction. First, the trading data of exchanges.
Yeah.
I would think that would improve the measure dramatically to include this data. And we have also ideas how to do it. So you might, for example, use just the transaction volume of the exchanges and use the money or the Bitcoin that are lying on wallets of exchanges and like weighting that and adding to the measure.
Yeah, I don't really mean the trading volume between Bitcoin and, let's say, US dollars on those exchanges, but for example, the sort of trusted wallets offered by those exchanges, like transactions between them, would not go onto the blockchain, right?
Yeah. This is more similar to this, to off-chain transactions like Lightning.
Yeah.
Yeah, this we didn't include. And honestly, I don't know right now how to include it. For now, we would say that there's so little in terms of that it's not really a problem for our study, but for the future, yes, that's an issue.
As layer 2 is more popular, maybe it'll be harder to measure velocity.
Yeah,
right?
yeah. Thank you.
I actually wanted to ask one question, which is related to this, so I'll just piggyback. In the beginning of the paper, you kind of frame most of your work really around the notion of velocity, like as an econometric measure, and Bitcoin kind of giving you unique insight into that, as something that's measurable. And to his point, this might get harder and harder. So I'm kind of wondering, like, are we in a golden era where you can actually study this thing uniquely, at which point it'll just get, we'll have private transactions and Lightning Network transactions and things like this. So is this the only time we'll ever be able to study the velocity of money?
It's a good question. I would say also for coins that are really focused on privacy. I think that it's because it's hard to cluster data. It's probably calculating our measure for those is not really applicable. Yeah, in the moment when we see really a lot of more privacy measures and also like off-chain transactions like Lightning, maybe we have come up with something, but in the moment, no idea.
Okay. Thanks so much.
Thank you.
All right.